Hey, we are live now. I clicked the lecture button. We could do the intro, but we're currently live. Let's get straight to it. Is anyone here in the chat and they have questions? We should be live. So you can't see, I'm going to start annotating on the screen here. Let's hop over to the screen. If you're in the chat and you have questions, feel free to ask a question you want about the test, a topic you want explained. So who's here and who's got questions? Any questions? Anything? We can look at the regression equation. Can you explain the IQR for the 5 odd numbers, the 5-number summary? So the IQR is part of the 5-number summary. So we're going to draw here a box plot. And it's important we know, let's draw them vertical today. We're going to draw some vertical box plots. So thank you for the great question right there. We have an example here of a 5. It's not going to look good. We want to draw our box plots accurately. So let's draw an accurate box plot. The whisker can go up 1.5 times the length of the IQR. So there's some outliers. That's pretty accurate. These box plots right here are going to, this one's going to be a little oddly shaped. And so when we look at this right here, we have some stuff. Austin, you are so right in the chat. Nice job in the chat. We're going to add in a green pen. But the IQR is this distance right here. That is the IQR. So you can see this box plot A down on the bottom has a smaller IQR than the other one. We probably need to go in here and we need to do the min, the Q1, the median, the Q3, and this is the max. Now the max doesn't have to be an outlier. Can you explain number 5 on the practice test? Yeah, let me bring that up here. So I think I've been doing that one a lot in Stat Lab, but it's a really tough one that a lot of people want help with, and I'm going to do that question. So let me grab the practice test. I need to log in. I don't think I have it currently on here. Let me get the practice test review material. So we just did, if you see what's in the background right now, we were talking about the IQR. The IQR is the distance from Q1 to Q3, and I'm going to pull up the practice test right here and show how to do the practice test problem. So I need to convert this to let me download it. Okay, Stat 201 Spring 2020 practice exam. So Stat 201 Spring 20. I think I already have it on here. Stat 201 Spring 2020. Okay, Stat 201 Spring 2020 practice. Where do I have it on here? Might just need to take it. Okay, let's look for it another way. Okay, let me do it via the download method because I'm going to do it that way. So I need to download and export this. So let's go ahead and download this. 2 seconds and we should have it right here. Let me go to open this and let me bring it into here. Okay, so we should be seeing it. Let me pull back up what people are saying in the chat. We got chat going on. Well, you have to interpret R and R squared. Yep, let's interpret R squared. We can do that next right here. Lots of great questions. So let's talk about this one right here on how to do question 5, part 2, and then I can do some R squared interpretations next. Okay, so we're going to go down to question 5, part 2. Question 5, part 2 is going to be this one right here. Okay, a particular cell phone has a battery that will last 2.5 years on average, and then we'll do number 4 next. With a standard deviation of 0.32, the standard deviations of these lifetimes is approximately normally distributed. Now here's what I would do immediately. I would start by drawing my curve. So remember what the question said. Let's take some notes on it. We have a normal distribution with a mean of 2.5 and a standard deviation of 0.32. Now what I need to do, you're welcome. You guys are so positive. It's so awesome. We're going to draw the normal curve right here. And sure, we can do better than that line. There we go. We like that line. And so let's go right here. And what we're going to do is we're going to put in our 3 standard deviations. The 3 standard deviations will be written the following way. You can always kind of do 0, 1, 2, and 3. These are the z-scores. -1, -2, -3. Now, I always say put your z-scores and then put the context. That says z-scores. I know it's scribble, but I'm writing z-scores in context. So I want to know the question with the z-scores, which I'm hovering over right here, and then I'm going to put the context below. So with this one with the context, the mean is 2.5. So that is a z-score of 0 is the mean of 2.5. So we are given a very small equation sheet for this test, very small, not that much on this one. Now we're going to go to 2.5 minus 0.32, and we get 2.18. all I'm doing is going down a standard deviation each time, and then this is 1.86. Please tell me if I get a number wrong. And this is 1.54. What I'm doing is I'm just subtracting each time. Take note that all I'm doing is minus 0.32 minus 0.32. Now, I would suggest writing out all the numbers, but you don't technically need them for this problem because this problem says a particular phone lasts 2 years. That's how long the observation is. So in the problem, they told us, 1, they told us the mean, and 2, they told us the standard deviation. So we know mu and we know sigma. And then the problem also told us why. It said a particular phone lasts 2 years. So from this, we can do the equation. Let's write the equation on the top right, above me right here, that we have, you are able to use those TI-83s. Yes, you are. We have here observation minus mean over standard deviation equals a z-score. So when it says that that phone lasts 2 years, we're going to do 2 minus 2.5. If you notice, I've got the notation on the other side. And this is just observation minus mean over standard deviation. And I'm not blocking the numbers yet. Good. And then we're just going to put it into the calculator, and it's about negative 1.55. And I want to show why I'm drawing this out to begin with. I'm going to move this over so you can see the equation while I'm solving it. We're just doing observation minus mean over standard deviation. So it's negative 1.56. And I think the test says, look at the first page, it usually says how many decimals to round to. TI-30 is great too. Don't worry, a lot of the advanced functions aren't needed. And a lot of people who say, oh, the calculator will save me, there's not a lot of advanced maths. If you notice, I'm not using a TI and I can solve every problem. Though the TIs are awesome, like the TI-83s, but if you know how to do the problems, you can do it with a basic calculator. Doesn't hurt to have an advanced TI, but don't go out and buy one, or don't worry if you don't have it. Knowing how to solve problems is more fun. You're great. Great job. Thank you guys so much. Let's go right here and take a look. If you notice, where am I graphing this line right now? Like, where is this line? This line right here is exactly where the z-score is at. And I want to make sure everyone sees that this is a negative z-score. But that line I drew is at a z-score of negative 1.56. And look, it would also be at the number 2, and it'd be at negative 1.55 or 56. 56 right there. So it's at negative 1.56. It's very important to note that our answers are correct and accurate right here. So this is the kind of easier part of the problem, I would say. A lot of people get stuck on the next part. We're going to erase some of our work. We understand how we got the z-score right here. We're going to erase this and know that we know what the z-score is. And let's clear up the room a little bit, to clear up the board a little bit to do the next part of the problem. Now what we need to do to solve the next part of the problem, we don't need the observation anymore, and we'll leave notation, is we're going to say, let's find the area that is shaded in. I'm going to shade in this area right here. This is the area I want. Question 5, part 2 says, what is the area longer than this? I just want you to look at this right now and just take a guess. Your guess should be definitely more than 50% because above here is 50%. And that's just a given. It's like Brian has shaded more than 50% of the curve. Now, you might get iffy on how much exactly it is because we need to box it in with the way this question is written. So what we're going to do is we're going to use empirical rule numbers and draw arrows that are too big and arrows that are too small. We got space pen for this, so we're good. Now, what I'm going to do is I'm going to go to the 2 closest empirical rule numbers. And I'm going to drop an arrow here, and I'm going to drop an arrow here. Why am I using these numbers? Because these are the 2 closest empirical rule numbers. We only know the percentages around the empirical rule numbers. We can't do like the betweens. So I'm going to draw an arrow this way. And I'm going to draw an arrow. We'll clear up the board a little bit up here. And I'm going to draw an arrow this way. We're almost there. We just need to figure out how much these areas are. And what am I showing to you right here by drawing these arrows? Well, I'm showing to you the following. The area I'm drawing right here is this. Now this first area is what? This first area is too what? It's too little. Where the second area I'm drawing is this. The second area from that arrow over is too much. If you notice, and sorry I got the extra shading over there, this is too much to graph from this over. So the area I want, which is from here over, has to be between these 2 numbers. So we have to figure out some way to say it's between this and this. We're going to be like lesson, and Elizabeth's right in the chat, 68, 95, 99.7. Those are the empirical rule numbers, which we do give to you on the test. Between here and here is 68. Between here and here is 95. So what we'll notice is we can draw an arrow this way and an arrow this way. Now, if you're wondering how I'm getting these numbers right here, if 95% is inside of my hands, that leaves 5% on the outside, which is 2.5 on either side. Now, right here, this one's going to get a little bit busy in the middle of this graphic. If 68% is inside my hands, what is total outside? If 68 is in my hands, total outside 32. I'm just subtracting from 100, and then I'm going to cut it in half for one of my hands, which is 16. So 16%. Now you might say, why did I do all this extra work when I just want the space pen arrows? Well, it's because I want you to watch as I travel across this. If I take this road right here that goes this way, I'm covering 100%. Look how I follow the arrows. So whatever is added to 2.5 to get to 100, look at this, would be the answer for the space arrow. Can anyone tell me what the big space arrow is worth? How much is the big space arrow worth? It's worth 97.5%. And why is that? Because it's, if you look down below, it's 95 plus 2.5. So, or it's 2.5 minus 100. So great job right there. And then the next one can be done that we have 16 right here, and we could travel across here to get the remainder. It's like the whole rest of the curve. So it's 16 or 100 minus 16, which is going to give us 84% right here. And so that has the answer right there. That is how we solve for the areas when we have to box it in like this. Know how to look at your graphics. Great job, Dylan, Maxwell, and everyone in the chat, figuring out these questions. And I'm kind of confused on what would be something like between blank and blank. This right here, this would be between, and we'll circle the numbers right here, between this number and this number. So the area right here has to be between those two numbers. And we could confirm this by going to the David M. Lane, and we wouldn't have that. But on the test, we could do pictures, and you might have to use something like that. So knowing how to, so we got the David M. Lane applet up right here. We're going to confirm our answer, which we can't do on the test, but we can do when we practice, is if we have 2.5 and we have 0.32 and we go to the area above 2, if you look at that, this should be between, like we said, 84 and 97.5. So that has how to do that question. You're welcome. Does that kind of make sense? Like, I'm just confirming my answer here. I wouldn't be able to do this on the test, but we said above here is 84%, and we can even confirm that by going right here and typing in 2.18. This should be about 84. This finds out the exact answer. That's about 84. And then above the z-score of -2, we said is about 97.5. And remember, this is going to give us exact answers, but this is what we also found. We found the other area, and we said it's between 84 and 97.5. Know how to read these pictures. Know that it's giving the mean, standard deviation, all that great stuff right there. So it wouldn't be a specific number. It would be between two numbers. We've done questions like that, and it could be on tonight's exam. It could not be. Don't be too scared. We're going to do more problems. We're going to do more practice. There was a question earlier about question number 4 on the practice exam, and we'll do that one here, and we'll hop around doing questions. Just put your question in the chat, and I will do as many of them as I can. That's what I try to do. I try to do questions. Okay, question number 4 right here is one of my favorites. Whenever you're given graphics like this, let's make sure everyone knows. This is Brian's tips to success. So we're going to get Brian's tips to success, and I'm going to take the right answer, and we're going to start working on it. We're going to pretend we already did everything we needed. We're going to grab our snipping tool, unless snipping tool's broken. Snipping tool's not broken. And we're going to take the graphic we need, because I've worked this problem a few times. If this was not the day of the test, I might not go right to the answer, but let's do it. So what question 4 goes over is question 4 talks about hockey reaction times in milliseconds. And so what we need to find here is the 75th percentile. So immediately you should understand how to read this David M. Lane graphic. Now what you need to do, first thing, is if you are given the context numbers, go below the curve and start writing the z-scores. Let's put this in red right here. This is a must. So 1, 2, 3. -1, -2, -3. Now, if a question were to ask me something like, imagine a test question were to ask you this. One hockey player gloats that their z-score is a -2.2. Can anyone take a guess of what their reaction time is? Just look at the graphic, and it says one hockey player gloats that their z-score is -2.2. What do you think their reaction time is in milliseconds? Now, you don't have to figure out exactly. Just use our cheat sheet right here to take a guess of it. So with that knowledge of the cheat sheet, and I think I have to scroll down in the chat. You guys might be answering. It is 128. You are right. The answer is 128. Remember, go to where negative 2.2 would be at, and you can actually kind of see, and you can solve the math, but it means they are 2.2 standard deviations below the mean. Now, it is important to know that we can use the following formula. We can use the mean plus the z-score times the standard deviation equals the observation. That's just a reworking of observation minus mean over standard deviation equals z-score. So these are two separate formulas right here. No worries, Jeff. This is practice time, and if you get something wrong now, you'll probably remember it. The more questions you answer wrong, the more things you remember. So keep answering. Keep it up, Jeff. So we got right here that this is how to take and turn a z-score back into an observation, and then this is how to get a z-score. Because think of what a z-score is. A z-score is just how many standard deviations an observation is above or below the mean. So when we say here that the standard deviation is 10, which you can see right here, each of these goes up and down by 10, someone was, if they have a z-score of -2, so this is a hypothetical problem, z equals -2, just tell me in words, they fell, or they are 2.2 standard deviations below the mean. Generally, you will be. I can't think of one where you wouldn't be, but you'll be given the standard deviation, and always write the context of the problem too. Always do that. One thing I love to do on this problem, I'm going to add in a white pen so I can actually solve it the way I want to solve it. There's a much easier way to understand this problem, and it's to do the following. When you're solving this problem, it asks you for the 75th percentile. Now, first thing we want to do is we want to notice that what percent, could you do number 13, 2? Sure, we'll do that one next, Elizabeth. If you notice right here, this is shading. It's a weird graphical thing. This one is shading 25% of the curve. So I'm going to go right here, and I'm going to put 25% right here, and put a little arrow on it. And I'm going to go right here and do 75%. Now, wouldn't it be great? Wouldn't it just be awesome if I could just take this? It's very similar to the practice exam, very similar, like lengthwise and everything, and question-wise to a certain extent. Wouldn't it be great if I could just take this and flip this around? Wouldn't it be great if I could just take this and just flip it around like this? Wouldn't that be just awesome? We kind of can. We can take this graphic and flip it, and I'll explain how. I'm just going to go here, and I'm going to draw the exact same thing. Does everyone understand why I'm saying flip it? Because if I want the 75th percentile, that would just be literally, I'll draw a little mini graphic of it. I'm going to draw what I want to see. It would be this, but it'd be shaded over here. Does everyone agree that if I could just do this, then the bottom half, which I'm going to shade with space pen, that's not space pen. We know what space pen looks like. So right here, below there is 75%. So this right here is what we want. We want the 75th percentile, which would be right here on this green line. So guess what? I'm just going to take this graphic and flip it. So if you notice, I'm going to go to the same spot on the other side of the curve. I'm going to trace up and do that. This right here is what I want to see. It's literally the same distance away. So it's the same exact distance away, and that's going to be our key to solving the problem. It's the same distance above as the other one is below. Does that make sense right there? We got number 13 and got number 7 coming up here soon. So what we need to do now is we're going to do a quicker solve on this to make it easier on ourselves. Don't do this on the test. But does everyone see that this number right here, I'm calling it 143. So what this means, and it's important to know how to read these, is that this line right here hits at, let's write in black, 143. Does everyone see that that is right where that line hits? Right here is 143. That's what that means. How much below 143 is 150? How much below 143 is 150? How much below 143 is 150? So we would take and subtract them to find the difference. If you're doing with all the decimals, just find the difference between them. How much below 143 is 150? The answer is 7. Nice job, Dylan, in the chat. 7. So how much above do we need to go? If that's 7 below, we need to go what to 150? Not 7 below, we need to go 7 above. And the answer, and we should be able to tell, if you carry all the decimals, it'll be a little different, but the answer is going to be 157. So knowing how to use the graphic is very important here. Being like, okay, this is the bottom 25%. I want the top 25%. I just need to flip it. And you have to watch out. We could give you the z-scores, stuff like that. So watch out. Watch out. It's a little tricky sometimes. Lots of great. Does that make a little more sense of this one? I know I'm doing some quick solves on these. I'm trying to take as many questions as possible. Did anyone feel like that makes a little more sense? And I beg of you this. You're welcome, Jeff. I beg of you, write on the test. Put all your knowledge, draw on it, do your in context. Does everyone see these numbers? These are these are the z-scores. This is the context. So I draw the context if it does not exist. I draw the z-scores if it does not exist. I label my percentages on it. And we tell the graders, give partial credit. So show that you know what the z-scores are. Show you know what the context is. Show you know how to put the percentages on there. Do everything you can to earn every point you can. And I think we had some more questions on... So could you do, number 13, part 2. Let's take a look at that. What is 13, part 2? I don't even know. 13, part 2. Will I get it right or will I get it wrong? We'll find out. 13, part 2, right here. Oh, fun stuff. Oh, wait, let's do some practice in the chat. I've got a lot of fun stuff on this. This is fun. I like this question. I have to copy it lest I can't write on it. I've got 1,000 new Word documents open. Random call. They can leave a message. So let's see right here. We've got it inside of here. And let's take a look. The following regression equation was developed after a large number of nursing students agreed to share their latest medical records. Cool. And now we need to write below this. Here's what I'm going to write on my test. I'm going to write below this y hat equals b0 plus b1x. Now, it's very important as you work these problems, you do the notation. I ask everyone in my class all the time to do notation to make sure that they have all the notation written for each problem to know what to write for notation. Mary was one of the nursing students in the study. Suppose Mary's weight is this. So when it says Mary has a weight of this, what is it giving us? It's giving us a what value. Mary has a weight of this. This is telling us Mary's what value. This is Mary's what value? This is Mary's value of what? If that's her weight, this is a blank value. Mary's something. Now I need to write something here. I need to write this in notation. This is the what value for Mary. It is the... Oh, no, it's in the chat. I'll write... Oh, wait. Oh, no, it's not scrolling. Oh, you guys are awesome. Sorry, I scrolled up and I didn't scroll back down. It's my fault. You guys are being awesome. Sorry for the delay there. I think there's a lot more questions. I'll finish this one. I'll take all those questions right there. So in between, so Adam, Barbara, and everyone else, I will answer all those questions in 2 seconds. We're going to do question number 2, and then I'll jump to more questions. So Mary was one of the nursing students. We know her X value. All we're going to do here now is we're going to go to the equation. I'm just going to do it quick for this one because I think this is the easier one. And I'm literally just going to put in 110. That will give me Mary's predicted height. So now, which actually it looks like we need to do, okay, so I need to solve this. I'm just going to go here. Mary weighs 110. Times that by 0.085. Please tell me if I make an error. Add that to 54.55. We usually have these exams be logical. So Mary is 5'4" basically. Oh, nice, Adam. You are awesome. So I haven't read much of the chat yet. Thank you very much. So this is 63.9 equals 54.55 plus 0.085, and then that was times 110. So this right here is Mary's predicted value. This is Mary's predicted value. So if Mary is actually 65 inches tall, we need to remember the equation that residual equals actual minus predicted. And this actually in notation stands for E equals Y, which is actual minus predicted, Y hat. So I like to just say residual equals actual minus predicted. And now we need to solve for this. So if she's actually this tall, so it'd be 65 minus 63.9. And that would equal 1.1. I think that's correct. So as long as I haven't made a math error right here, we've subtracted her actual height from her predicted. And if you think about this visually, it would be the following. She would actually be a point above the line. Like she's taller than what we predicted her to be. So she's 1.1 inches taller than what we predicted her to be. I think there was, Yuting has a question too. And I think Adam did a great job. Yep, taking out the outliers make the rest more linear, which means the two variables become more related. Pretty much. Will the question be out of points so we can still get points on the question? Yep. You get partial points. How many questions? The exam is very similar to practice exams. Practice exam is all this, very similar to each year. Not the same, but for number 7, continued. The answer is D. Can you explain? Number 7. And lots of questions chat. Let's hop right here. Number 7. What is number 7? This one. Okay. Oh, and they already did it. I'll talk a little bit more on this one. This is the one that people were asking about. And actually, we need the graphic. I think I can draw the graphic. Cool. Okay, we're going to redraw this graphic right here. We're going to do it in a Word document, because what else are we going to do it in? And let's hop in here. Let's drop it in. And let's draw the plot in here. So it's important to know that outliers can do what? Outliers can do anything. So what you've got, if you've got this big space pen point right here, and so what we need to know is that outlier is actually going to make correlation weaker. Reason being is this is what the correlation looks like without it, and this is what the correlation looks like with it. So by taking out that outlier right there, if you removed it, the correlation would get closer to 1. Oops, wrong 1. It's going to get closer to +1. Closer to +1. If you notice, the ellipse is wider, making it more like a 0. If the correlation looks more like a 0, it's closer to 0. And if the correlation gets tighter, and by tighter we mean kind of this right here, that's what tighter is. When it's tighter, it's more like a 1. And when it's wider, it's more like a 0. Dylan, you are being awesome right there. Given a set of numbers. Usually we don't do the IQR from numbers, so Yuteng, great question. I do that in a video on the box plots that's already up, but I will say this, usually we're not calculating the IQR from numbers, usually we let software do that, so hint for the test. Can you do part 4 of question 13? I believe, Dylan, and don't worry about it too much. I did one, there's one, I think, Higgins review has it, where it gives you like 10 numbers. Just briefly, I mentioned right here. 10. If you have 10 numbers, this is where the median would be at. And this is Q1 right here. And with 10, wait. Okay, guys, just that 10 is a bigger number. So that's Q3. And don't worry, we don't have you calculate. I say don't worry, and I'm like, I've seen the test, I'm trying to think. It's just that usually we let software do this. We could have you calculate the median, but the IQR here would be 5, which is the range of the middle 50% of data has a range of 5, going from 3 to 8, and the median is 5.5. So the median is a number that actually doesn't exist, so the median is 5.5. But usually we don't have you calculate the quartiles. So even if I'm in your class, would it be worth it to look over the Higgins? Yeah. No, the Higgins review is great. That's why I posted it. People last year were like, hey, can I use this? And I was like, sure, yeah, let's look at it. But all that great stuff. No, so, and that's posted. There's videos for it. So if you want, with the limited time, you could watch the video review, whatever you want. I go over that last semester or so. That's why I'm just here to answer questions, because I know there's a lot of video reviews, but I'm doing as many things as people are stuck on, like, hey, Brian, I don't understand this question completely, and I see question 14. Sorry if I know there's been questions I maybe missed. We're going to go to question 14 right now. Oh, I love some question 14. All right, so for question 14, we're just going to grab the bottom of it, and let's talk. This leads to a bigger talk. Okay, we're going to slow down our brains a little bit here on question 14. Okay, so here's the problem. It's a good way to start a review. Here's the problem. So the issue is, a lot of times when people hear p-values, they might say things to me like, and don't worry, I hear this all the time. So you'll be like, I said that to Brian. I'll be like, don't worry, everyone says that to me. They'll be like, it's normal. And I'll be like, well, if we're testing for normality. So if you notice in this question, above here was, before I made it go away, above here was a plot that looked something like this. Just a plot. It had an x and a y variable, had an x and a y. Cool. So, and the x was arm length. So that's arm length. And the y was head circumference. So with this in mind, let's think about what we're doing here. We're doing regression. Now, whenever you see p-values, there's 3 times, and I think I have a review video up for this too on a speedrun. We did p-values on normality, we did p-values on correlation, and we did p-values on regression. What makes an outlier data set too extreme to do a regression on data set? We usually try to make outliers very, very obvious. So when you see like this, I wouldn't say that this is outliers, but if we do an outlier on the test, usually we're gonna, like the one you saw previously, we kind of made it like ridiculously obvious. The thing is, when you look at plots of data, like when this one you look at the plot right here, you don't want to give a failure of a condition. So we usually say, the one on the left, the far side of the screen, way over there, like way over there, looks pretty good. It's got some weirdness, but it looks pretty good. Then the one above me is like, that has a huge outlier. That's a big problem. If I see an outlier, I'm probably going to circle it and be like, hey, there's an outlier right there. There's something going on. So I would always suggest that if you mark that there's a problem, make it super clear that there's a problem and try to make it more obvious. You could even mark that you're considering something. The graders, especially, and if you go talk to your teacher, if you're like, hey, I think that this is an outlier right here, it's probably not. We have other ways of looking at it with more advanced statistics, but it's just kind of the furthest point, and it's not really an extreme outlier. It's not very bad. So we always go for a bigger problem, and this one that I still have on the screen is a big problem right there. That is a huge outlier, big problem. And use the p-value of the slope. Yes. And so Jeff is right on this problem. We're going to look at the p-value of the slope right here. Now, why is it the p-value of the slope? It's because if we have a line and I change the intercept, that does not change the xy relationship. Now, if a line is flat, x and y don't have a relationship. It's like if I change x, y does not change. Not literal change, but changes in x don't equate to changes in y. But when you have a line like this, all of a sudden now, as x changes, y starts to increase. So we need to think about where we want to see the p-value. And one thing I really want to highlight, literally highlight, is that if you notice here where it says prob, that's why we call it p-values, because the p-value is the probability of our results or results from our extreme happening by random chance variation given that the null is true. You don't need to memorize that. But the prob right there is the p-value. So when you see prob, you should be like, p-value, that's what that prob is telling me. That prob right there is telling me p-value, and you've got two p-values, one for the slope, one for the intercept. The intercept controls this. The slope controls this. This is the xy relationship. This is a negative xy relationship. This is no xy relationship. This is a positive xy relationship. So it's important we know that the slope is the one telling us if x and y have a relationship. The stronger the slope, as in if we see a slope that looks like this, guess we'll go for statistical strength, so not strength as in higher slope. So let me not confuse everyone because I know I just said a lot right there. This slope right here is very statistically significant. Although the slope is not a big number, it's that it makes such a strong line. This one right over here is actually a weaker relationship with a stronger, a more positive slope number. If it had the same XY scale, this one has a less of a numeric value of a slope than this one, but the one on the far side, graphic A, is going to be more statistically significant than graphic B. So when we talk about something that is not statistically significant, what would we expect to see? If there's no slope, what do you expect to see? You expect to see a line that is flat. So this is when you get a high p-value. P-value for this one, let's just say p-value equals 0.98, and p-value for this one is like 0.0000001. Do you need to know anything about putting data into pivot tables? Yeah, decently. You should understand what we can do with pivot tables, with the columns, the rows, the filters, columns, rows, filters, and value field setting, which is the value field. You should understand that we need chart titles, access titles, data labels, data tables, things like that, like how to make a good pivot table. Really, the best way is to get a good grade on the project, and then you pretty much understand what you know on the test. I would say if you understood and still understand how to make a good pivot table and pivot chart for the project, you should be pretty good for the test. Pivot chart's not the hardest thing. So statistical significance is like having yes. The significance of the slope is the same way of doing the significance of the correlation. So correlation and slope are virtually identical topics. Closest to zero means more significant, correct. If you look at this graphic right here, which has a p-value closer to 0, we're saying that this relationship here is unlikely by random chance. And that's what this question gets to at the end of it with part number 3. The low p-value, which I've space pen highlighted, let me make sure I'm not giving a wrong answer there. The space pen highlighting right here has the correct p-value circled. It is statistically significant because the p-value is less than 0.05. So that is literally the definition of statistical significance is p-value less than 0.05. And we see here that we have a line that is unlikely by random chance given there is no slope. This question, part 3, was probably one of the most missed questions on this test. Can I give you a definition of what the filters values are for? If we have data collected on students and we want to remove like seniors, like we have freshmen, sophomore, junior, seniors, and let's not include the seniors, we can put class level in the filter and filter out. So filter just allows you to remove certain characteristics. Like let's say we're like, let's look at non-Tennessee students. So we could filter out Tennessee students by just putting in non-Tennessee students. So filter just allows you to remove out certain groups. You wouldn't just remove out that characteristic. You'd remove out all Tennessee students. P-value greater than or equal to 0.5 is not statistically significant. Be careful. It's reversed right there, Dylan. P-value less than 0.05. So the one I've highlighted on the far side of the screen is statistically significant. This one right here is not. This one right here is statistically significant. So the one that I said is below, oh, you're fine. And it's technically less than. We'll never do a 0.05. That's mean. Also, you'll notice jump. I'm going to highlight it for a second. Jump puts the p-values that are statistically significant with a star on them. So the one up there is not statistically significant. What we're seeing there is likely by random chance. It's just like, it's a scatter of points, nothing going on. It sounds like I don't know where I'm from. But and then the one on the far right, or the far side of the screen right now, is a relationship between data that is unlikely by random chance given there's no slope. Could you define statistical significance as the likelihood that the relationship between two or more variables is due to something other than... Yeah, that's good. I think it's decent, Adam. We just say it's not likely due to random chance. So yeah, usually we say it's the probability of our result or results from our stream happening due to random chance. And so you could say if it's statistically significant, it means that it's likely that our results are due to something that is not random chance, because we don't think it's from random chance. If it's statistically significant, the probability of it being by random chance, the one I've highlighted over on the far side of the screen, it means that it's unlikely by random chance, so it's something else probably. It's probably that there's a relationship between the points. If we find r from r squared, how will we know if it's positive or negative? Great question. We're going to focus on that right here. Go ahead and for right now, solve for me from this question what the value of correlation is. Who right now in the chat, for 1 point, not on the test or anything, who right now can solve the value of correlation and tell us how they did it? We're doing some practice for the exam right now. We're going to get correlation on the test. And who can tell us how to get the value of correlation? Who knows what the value of correlation is from this graphic right here? You're fine, Dylan. You got this. I got faith in you. Bit the test later. That sounds about right, and I think it is, because if you times 1/3, you get 1/9. So let's take a look. Here's how to get it. And is it positive or negative? Positive or negative? How in the world am I going to know if this is positive or negative? Don't worry, it's a very good question. That's why I take, if you ask a question I don't do it, it's not because it's not good. It's just because a lot of questions, but this is one of my favorite ones to make sure people know. R is positive if the line has a positive slope, and negative if the line has negative slope. Raneem, you are correct. Great job right there. Let's go ahead, and I'm trying to find the square root button. Hard to see that. There it is. That is, r squared is always positive because you square it. That is correct. Jeff, you're welcome, and thank you, everyone, in the chat. So we have here that the correlation is kind of a moderately weak positive correlation. We're going to space pen a few more points a little further out to make it weaker. If you notice, I'm making it a bigger blob right now to make it graphically weaker. And then I'm going to do a few big things, and we'll hop to Mary's questions right here next. Some things I want to point out is, one, who can write in the chat right now the interpretation of the intercept? Who can write in the chat right now the interpretation of the intercept? Practice this, and I'll say it once you write it. Who can do the interpretation of the intercept in context of the problem? What would happen if a condition wasn't met? Mary, I can answer that right now while they write interpretation of the intercept here. If a condition is not met, then regression is kind of not proper. There's kind of issues, and we might be doing bad statistical techniques. We might not be reasonably explaining reality. Can you give a definition of what a residual is? A residual is how far off the model misses. So residual is actual minus predicted. So when we do a residual equals actual minus predicted. When a residual is positive, it means that the point is above the regression model. When residual is 0, it means it's on the regression model. When residual is negative, it means it's below. So the residual is just how much the model misses by. Anything above has a positive residual. Anything on the model has a residual of 0. Anything below the model has a negative residual. So a residual is just how much we miss by. It is literally the distance the point is away from the model. So the biggest residual here is this negative one, which is the most below the model. The model being the line. The line makes the predictions. So we get our predictions from the regression line itself. Does that help right there, Austin? I hope it does. And so we see if the arm length is equal to 0, we expect head circumference. Good job, Austin. So if arm circumference is equal to 0, we expect the head circumference to be 46.78 inches. Amazing job, Raneem. Awesome answer. A+ right there. If you have no arm length, exactly. So it is when arm length is equal to 0, and if you have no arm length, we would expect. This is illogical because it doesn't really make sense. How about for that slope interpretation? And remember, in the chat right now, I'm going to write the blanket interpretations, things you should know. If x is equal to 0, or let me say when x is equal to 0, we expect y to equal b0. And then the slope is going to be for each 1 unit increase in x, we expect y to increase or decrease, don't say both, by b1 on average. I don't really care about the on average, but your teacher might. And then also blank percent of the variation in y is explained by the variation in x. Okay, cool. Whoops, messed it up. There we go. Okay, so practice. Who's got my slope interpretation for me? Because we need to do this in context of the problem. We need to interpret the slope interpretation right here in context. For every additional centimeter in arm length, we would expect the head circumference to increase by 0.14. You are right, and then throw the on average if your teacher cares for that on the end of it. Long story. I've gone through it multiple times, so I don't care about on average. It's because we can do better interpretations. Two individuals who differ by their arm length. I'm not saying it. Sorry. We're studying for test today. That's what we're getting ready for. On average. Great job, Abigail. Who's got me my R-squared interpretation? Yeah, Mary, we'll do that next right here. Who's got my R-squared interpretation in the chat? Who's got that R-squared interpretation? We're going to say blank percent of the variation in y is explained by the variation in x. Make sure to give that. And we repeat in my class all the time that R-squared is not R. R-squared is called the coefficient of determination. You don't need to know that. But R-squared is not R. R is correlation. R-squared, Carlos, you are right. Now make sure to put in the variable names. Barbara right now says 11.6%. You are correct. So let's put it all together with Carlos and Barbara's answers right here to what is it going to be? 11.6%. Be typing it out while practice right here. 11.6% of the variation in head length. Is that right? Head circumference. Having 11.6% of the variation in head circumference explained by the variation in arm length. Rachel, nice job. Amazing answer. A+ answer. So that's got it. Basically 12% of the variation in head circumference explained by the remember to add variation in arm length. So Dylan, remember to say variation. That probably, if the grader said, should I take off a point? If they were asking me, I'd be like, just give it to them. But if they took off a point, I'd probably be like, okay, whatever. So there's iffy things. Add in blank percent of the variation y is explained by the variation in x. So great job, all those answers in the chat. The question is, how do we find B0 and B1? It's important we know our output. So make sure to know your output. So let's look at the output right here. Do we get everything off the screen? A little more space pens. Can't have space pen. So we're going to go here to the output. We're going to zoom nice big on it. It's important we know that in our output, the equation right here, let's space pen it, bring back the space pen. This equation right here is going to be y hat, and it's going to be equals B0 plus B1x, which makes this value, we are predicting head circumference, and then we have here B0, and then we have B1x. X is arm length. I'm going to use a smaller pen for the next one. Down here, you see B0 because that's the intercept. And then you see B1, and you see the name of the x variable. Right here, you see the significance of the model, which is the significance of the slope of the model. So it's important to know your output right here. The only other important thing we have in this output is the following, and I guess maybe that matters too. We see here the R squared, which is the percent of variation in Y explained by the variation in X. We see that there were 98 observations. We have the coefficient of the intercept, which is 46.178. We have that also written up here and down on the bottom. Then we have the coefficient of the slope, which just means number. Coefficient just means the value of it, and it's 0.1398624. And that's also up at the top. We have the name of the X variable, which is arm length, the name of the Y variable, which is head circumference. Does that make more sense of this output? And that is the significance of the model right there. Hopefully, I know I'm doing things a little bit quickly, but ask your questions in the chat. So we ever have to find B0 and B1 by ourselves? Nope, not with those. Not with the standard deviation of Y and standard deviation of X. Don't worry about those. We don't put those on the test. A little too mathy, and we do statistics. We don't do math. We do stats. So we expect you to know how to interpret and understand data, we try to do fewer math equations. There are math equations. You will be solving and predicting things and finding residuals, but we never make the math too difficult. Some questions can have a tiny bit of a challenge, but our goal is not to make it less of a math exam and more of an interpretation exam and understanding concepts and knowing statistical concepts for like research or graduate school or applications in business, because we service so many different types of students. A lot of business students, lots of general education students, science students, you name it. So our goal is to give a broad range of how we use statistics. You're welcome, Mary. Another question, another one from, or you can say cover this topic. What topic do you want to hear about? I'm going to go till right at 5. And thank you so much for who's ever here. I don't know how many people do we have watching. I didn't see. I'm going to go cheat and look how many people are watching. 85. Whoa. Thank you, everyone. That's, wow. 85. That's craziness. The chat says, did I miss the Kahoot? Oh, Calzone. How you doing, man? You are a legend. The Kahoot was, look at that. Everyone, I talk about you in class. I'm like, he's awesome. We will inform you. Feel free to email me, bstevens@utk.edu, and we can get you in on the next Kahoot. Remember, I will send you that Starbucks gift card, and we'll give an extra one out. I need to remember to bring mine to the exam if people want it. The Kahoot was Friday, so check it out, and always glad to have you. That's why you're a mod, because you're awesome. So he came and visited us from New York, and we love it, because I'm from New York. And so is Steve Rogers. So there we go. Can you look at question? I think Jeff wants look at 13 part 4. 13 part 4. Let's take a look at 13 part 4. Yes, Maxwell wants it too. So let's go to 13 part 4 for everybody right here. And question 13 part number 4. Oh, whoo, this is where it gets a little more difficult. Okay, so if you look, we're going to take and we're going to copy this twice to kind of keep the equation. Okay. I need to zoom out again. This is probably one of the top hardest problems. I know I've said that twice, but I will say something when it's one of the more difficult problems. So let's hop in here and go here, paste it in. We're going to get the full equation on the screen, and we're going to do the following. We're going to crop the image. Crop image. And crop is amazing. There's that. We're going to put the other image on the screen again now. 2 seconds while this fixed up. We're going to crop this image now so we can see it nice and neat here for presentation purposes. Okay. Now, the biggest thing with these questions is knowing the tips for solving them. So at this point, we want to understand how to solve these questions. Question number 4. Yeah, I think we did that one earlier, but we can do it again here if you want. Okay, so let's look at how we're going to solve this equation. All right. Every time you get something like this, you need to mark your notation. I can't state that enough. So when I see this problem right here, I'm going to put right here that we're going to put y hat equals b0 plus b1x. We know the notation. We're good. Now it says, John, another nursing student that was part of the study, is 68 inches tall. That is John's height. Someone please tell me what I'm going to put in notation right here. This is John's height, his actual height. That is John's actual height. Since that's John's actual height, what is that in notation? That's his actual height, not his predicted height, not his weight, not those coefficients. That's his actual height. What is that in notation? Put in y. Barbara, you are on track. Nice job. That is y. So now we know what y is. We used the regression to find out John's predicted height and then calculate the residual from it. So now we need to know this is the residual right here. We can write here this is E, and we do give this to you that E equals actual minus predicted. E stands for residual, and you can call it residual equals actual minus predicted. If you notice right there, R stands for residual, A stands for actual, P stands for predicted. Y is the actual, that is John's actual height. If we were to predict his height, we'd get his predicted height. So, and then question 4, Braden, we'll do that next right here. And I think a lot of people want question 4. Yes, so check that out. Adam, you are awesome. So check out that timestamp right there that Adam has, and maybe if you're still stuck, we'll go back to it. Adam, you are awesome. Adam, 10,000 points. So with this right here, and we did some interpretation residual, we'll do that in a moment again. But we have here, we are going to take and find what from this? Think about this. Right now I have his residual, negative 1.47 equals, and then I have here his actual height. Does everyone see I'm just using the numbers I gave? I figured out his actual height because it gave it to me, and then I figured out his residual because it gave it to me. And so I'm going to use these values to find out his predicted. So actual minus predicted. And if you notice, I should get a negative number here. So I'm just going to solve it in my mind. Solved in my mind now. So y hat equals 69.47. Now, you might want to plug it back in to make sure you have it correct. I'm just going to plug in my calculator, make sure I got it. I'm going to go actual minus predicted because I'm saying that's the predicted value. I get the residual, and I can also do it where I do the mathematics with the algebra. But this confirms by doing actual minus predicted that that is the residual. So yep, you are correct. You can subtract 68 from that, then you'll get negative y hat, and then you can just make them both positive because times it by -1 keeps the answers the same. So we have found his predicted height. But this question does not ask us for his predicted height. This question asks us for his weight. John's weight is his value of x. It wants John's weight. So remember, if you're answering this, you'd be saying John is 69.47 pounds, but that's not true. John is 69.47 inches tall. So we need to take this y hat, and guess what? We already have an equation on here, equation at the top of the screen right there, where it says that y hat, which is 69.47, is equal to, and then we put right here 54.55, and then we do plus 0.0855, and then we times that by x. So now we're just going to do the algebra part of this. Nice job, Dylan, in the chat. Excellent work, because we're just solving for x now. And so I'm going to do where I take and subtract from 69.45 minus off 54.55, 14.92. So 14.92 equals 0.0855x. And then all I'm going to do is divide the other side by that, and that'll solve for x, because we're just algebraing. This is about the most complex algebra gets on the test. So this is, and we don't do a lot of questions like this, as long as I carried all my decimals, then we find out that x is 174.5. So 174.5 is John's weight, and so we'll put here weight, which is x. Weight is x. Weight is the x variable. And so make sure your answer is logical, because if I'm saying someone is 174 pounds, does that make sense? 174.5. Yep, makes sense. Date, good one right there. Date, when we think about it, you can say like how many days are between, things like that. So you have to think about how to talk about it right here. So are we going to have to interpret the residual when we find it? If so, then what would we say? We don't really interpret the residual that much, but remember how residuals work, and remember how to make a residual plot. So when we make a residual plot right here, practice test is pretty good. I always say if you can ace the practice test, you should make probably a high C at least. And I'm not saying like, oh, if you ace the practice test, the test is going to be different. But I think some people over-practice the practice test and like only learn the practice test. It's usually got about 70-80% similarity. So if you ace the practice test, you have a good understanding of what's going on. I'll draw a flat one right here. It's just, you can't only study the practice test. Does that make sense? Like if someone was like, I'm never going to class, I'm just going to do the homework and do the practice test. you'd probably make a C if if you only study the practice test. But if you go to class, do the homeworks, understand what you're learning, then you'll make an A. Some people take the test and very easy, but it just depends how the data set's structured. I'd have to see the data set. Date's one of those confusing ones. You'd have to look at the data set to see how it's structured, because identifiers will not ever repeat. If it can repeat, it can't be an identifier. So let's make that very clear. If something does repeat or can repeat, so if we're looking at if I took track of when people came to my office, then if I had the date people came to my office, that would not be an identifier, because identifiers have to identify. So when something is an identifier, it has to be unique. Once something repeats, it can't be an identifier. And you have to think about how it can never repeat. Even if I just had students, like a student come each day, and it was we didn't have multiple students come to the office, it would still not be an identifier because multiple students could come to the office on the same day. I'd have to give a visit number as the identifier, like you are visit number 12, and that would be the identifier for that data set. So identifiers will not ever repeat unless time machines are invented. I like that right there, Adam. So we have right here a residual plot, and a residual is just how far something is away. So when you look at a residual, it's just how much the model misses by. I should have drew it where it was at. It's a little further over than it was. So let me make that a little bit better, because if this is the residual plot, that dot right here is going to be in the same spot right there. So the residual is just how much we miss by. The residual is just how much the model misses by when it makes the prediction right here. So a residual plot is literally just take your plot, make it flat, and this one would fail what? If QQ straight enough, no outliers, plot doesn't thicken. The 3 conditions are QQ straight enough, no outliers for correlation. And the 4 conditions are QQ straight enough, no outliers, plot doesn't thicken. So what issue would this one have right here? QQ straight enough, no outliers, plot doesn't thicken. And I do have a really good video on that too, but feel free to ask. This one would fail what if QQ straight enough, no outliers, plot doesn't thicken? What would it fail? Any ideas? Oh, the chat is silent. Oh no, I've stumped them. There is an outlier, and the reason we say no outliers is because we want there to be no outliers. Am I on? I'm on low latency, I believe. You'll sometimes see points that are further away. I wouldn't call these outliers, just points that drift away. How much of our work do we need to show on the test? Show all your work you can. If you have a right answer, you have a right answer. That's the way we grade. You get the answer right, get the answer right. That plot up there would be straight enough. If it's not straight enough, you'll generally see something like this. This is a violation of straight enough condition. The one up here, let me highlight it. This is a residual plot, it's the same plot as the other one, but it's just the line flat. So you take your line and you make it flat to make it a residual plot. So it's the same plot with the same outlier, just a residual plot. None of these, this one's getting a little iffy on that. Ren, amazing answer. This one's getting a little iffy. I'm going to make it more like plot thickening. Now that definitely violates plot thickening. We try to make it definitely more obvious on the test. This has an issue of plot thickening. That's got that issue. This has straight enough issue. This has outlier issue. Outlier. So we see a outlier issue. We see a plot thickening issue. Also important to note that the plot could get thinner also. It doesn't have to get thinner or thicker in one direction. It could do something like this. And that's the predictive power of the model getting worse. So QQ straight enough, no outliers, plot doesn't thicken. And do write quantitative variables or something like that if your class wants. But I just remember QQ straight enough, no outliers, because QQ means that both variables are quantitative. The one right here, closest to me, does not meet the straight enough condition. And actually, in truth, if we were to draw a line through that, the line would be flat. So I should do it proper. It would have a flat line through it. What other questions are there? And Terry Scuzzy says, unusual features, does it mean we put no outliers on the test? I think you're talking about, great question, you're talking about strength, direction, form, and unusual features. So talk about that real briefly here. Talking about strength, direction, form, and unusual features. Okay, so strength, direction, form, unusual features. It's good enough for my class. I would definitely write out quantitative variables if you're in another class. But it's like, it's not as funny as you say quantitative variables straight. It doesn't work. It doesn't work. You say QQ straight enough, no outliers. So yeah. Question 5, part 2. I think we'll hop back to that. Or it's also in the video, Ben. I think we did we do that one to start? I think I can do it again real quick here. Okay. We'll talk about this real quick, then we'll do Ben's question right here. Okay. So strength is how tight it is. When we talk about strength increasing, you can have a strong relationship that's not linear. So this is strong because of the tightness of the points. This right here is strong and strong and linear. These all are strong so far, but this one here is the weakest. This is a weak non-existent. Direction, we only have 3 directions, and I'm losing space. I need to move this down a little bit. Need more space. Direction goes the following way. Either it was positive, negative, or neither. And neither can be some additional, like, that's a neither. So that really doesn't go in either direction. This is like a neither non-existent. That's a neither non-linear relationship. Negative linear relationship, I'm talking about the form of it also. And then here we have the form of it. The form is either linear or the form is not linear. So really linear or not linear for the form. And then unusual features are things that are bivariate outliers. So an unusual feature is going to be something like you have data points like this, and this would be an outlier down here. You could have data points like this, and you could have an outlier somewhere over here. So that's what it is right there. 5 and 7. Yeah, 5 and 7 are where I see a lot. And everything is an important chapter for the test, but I usually see 5 and 7 where people lose points. Regression and normal model, people underestimate those problems. Always look at the practice test problems. I think usually the videos are a good help for that. I think we did 5 part 2 earlier. So I want to do this to end because I've only got 7 more minutes. Let's talk about some big tips for the test. 1, yeah, everyone wants that right there. People in the chat are saying do that. So let's take a look at this. When you get your test, I would almost take and draw on your curve, on the back of your test. Oh, whoa, I'm going to flip the whole page. I would draw out your normal curve, and I'd put the following. Now, knowing how to use this is important. If you just memorize how to draw this and you have no idea how to use it, you'll get stumped. Now, I know the numbers. I don't know how everyone else knows them, but I'm going to try to talk through them with you. So I'm going to draw the numbers on the inside and then put the numbers on the outside. What you want to do is you want to use your empirical rule numbers, and you want to use these for hints for problems. So we're actually going to swing back. Ben, we got you here because, Ben, we're going to do this all, and we're going to solve Ben's problem. So if you notice, we have our 68. 68 is between -1 and 1. So let's do our -1 and 1 right here. I would draw this on the test to start. So -1 and 1 is where 68 is. If 68% is between here, then that puts 68 in my hands, 32 outside, 16 in either hand. And then we go to the next one. We do -2 and 2. You should know these numbers now, 95. If 95% is between here, 5% is total outside. Do the total adds up. And then we get 5% right there. Oh my gosh, what am I doing? What do I need to do that 5%? You know it. It's getting close to exam time. That was just a trick to see if you were following along. We need to cut it in half. And then right here, we do the 99.7. Everyone makes mistakes. That was actually a mistake. I looked at it and I was like, what am I writing? So now we have 0.15. This just takes practice. Hopefully, if you haven't know how to do this, it's not like this will solve everything for you. How many decimals do we need to carry? I think it says 2 on there. Thank you, the chat's saying it. Chat's like, 2.5, Brian. You've told us this 1,000 times. It's 95 in the middle, 5% on the outside. Cut it in half to 2.5. You got this, Brian. Thank you, chat. So now what we're going to do is we're going to go down here, and we're going to start doing the inner arrow tricks, where we take 0.15 right here, and then we take the distance between these 2 arrows, and that's going to be 2.35. So we're just going to go between the arrows right here. Then we're going to go between these 2 arrows. Does everyone see I'm just taking the distances right here? And this is going to be 13.5. So I'm just doing the between areas between them. Next, I'm going to go here, but if you notice, when I go here, that's half of 34. So half of 38 is 34. And guess what? It's symmetric from here down. So we've now labeled all the between areas. We're almost done. That's 0.15 behind my head. Next, we're going to do the following. We're going to put some additional numbers. This is our big cheat sheet for the test. And our final numbers are going to be this. We're going to go right here and label this the 0.15%. So we're going to go here and label this the 0.15%. And then we're going to label this the 2.5%, the 16%. Do you see how there's 16 below there? 0 is going to be the 50th percentile. Now, this is where I add 34. I'm just adding the numbers under the curve. 84, 97.5th percentile, and I'll move my head in a moment here to 99.7 or 85 percentile. Wow, I see that mistake all the time, and I almost made it. So if you notice here, we got all the percentiles, and there is the areas you can check because above 99.85 should be 0.15. So it makes sense the 99.85th percentile would have 0.15 above it. The 99.7 percentile would have 2.5 above it. And so I think question 5, part 2, which we're looping back to right now, and we're going to show how with this, we will be able to solve this. So this is why we write these things out. We have question 5, part 2, and question 5, part 2 says we need to find the area above 2.2. Now, if you did the first part of this problem, you should have the z-score. Can I alt-tab back? I can. When you solve the z-score for this problem, it's going to be right here. We're going to destroy our graphic with some space pen. So if you notice this, we need to do the arrow trick. And so we did this earlier. We need to find the area above here and the area above here. Now watch as I go across this train right here. I'm going to go choo, 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 and then go down here and go across. That is 100% of the curve. So what do I do? 2.5 or 100 minus 2.5. So using my graphic right here, which I did a longer solve of this earlier, this long arrow is 97.5% of the curve. Also notice what percent should be below it. There. So 2.5 is below it because that's the 2.5th percentile, and 97.5% is above it. And then right here, we see 16% is below here. So that means 84% would be above here. And we've done it. You look at that. We had 1 minute and we got it. So this is the big part to drawing your curve if you do get presented with something like this. And I do suggest this. Draw your curve, make your notation of it, put as much work as you can on the test. So I've got other videos going over this stuff. If you guys want, after the test, tell me what was helpful to you because I'm always trying to make the most helpful videos as possible. So when people say do this or appear live more often, I'm here to help. Good to have you, Charlie. So I'm probably going to head off. I'll see you at the exam. Are you? Yes, I am. It's Captain America Day today. So it's all the good stuff. I will see people at the exam. See you in an hour. See you guys too. That was very helpful. Glad to hear that. And so we'll end with some Rick and Morty and have some great fun and see you guys later tonight.
Like TV from other dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.